Assalamualaikum and salam sejahtera. My name is Hariz Effendi, with the partner of Amirul Fikri and Farez Amirul. We are going to present about open display with running LED. So firstly, we are going to present about our code first.
The memory starts at 1000. Move byte is used to declare port B, port A, port K, port E, port H, and port T, while port J is used as ground. Move byte $FF port A is used to turn on the letter O with the delay of 500 milliseconds. Next, port K will turn on letter P and with the delay of 500 milliseconds and goes on with letter E and N for port E and port H respectively. After all the LED is turned on, it will stay for 500 milliseconds. Okay. This is for the running light and it is used in port T. There are 8 rows. Each row contains of 500 millisecond delay. And it is declared using 0, 1, 2, 4, 8, 10, 20, 40, and 80 as the location of the running light. As we can see, row 1 is used as $80, row 2 $40, row 3 $20, row 4 $10, row 5 $8, row 6 $4, row 7 $2, and row 8 $1. Each contain of 300 millisecond delay.
Bismillahirrahmanirrahim. My name is Amirul Fikri bin Amran, and now I will explain about the blinking of the box and the delay. So this is the coding for the blinking of the box. Firstly, this is move byte $FF port B. Port B where we assign the box, and FF is where we turn on the box. Next is JSR. JSR is where the calling function. The calling function is, let me make an analogy, where the blinking is the mother, all of this is the mother, and the D500 millisecond is as the son, and JSR is the calling function where the mother will call the son. And JSR D500 millisecond is a function of delay 500 millisecond. Next is move byte #0 port B. This is where we set the port B to turn off. Hence, it will make the box look like it's blinking, and it will turn off for 250 millisecond. And this blinking coding, it will repeated for 5 times. As you can see, we have 1, 2, 3, 4, and 5. It will blinking 5 times. Scrolling down to the next coding is the turning off of the box. From the top is move byte #0 port A. The move byte #0 port A will turn off the letter O, where we assign the letter O to the port A, and #0 means that we set all port A to the ground and it will turn off the letter O. Next is JSR D500 MS. This will delay the turning off of the letter O for 500 millisecond, followed by move byte #0 port K. This will turn off letter P, and then JSR D500, which will delay the turning off of letter P for 500 millisecond, and next is turn off letter E and letter N. The turning off of the box is in sequence, which is will turn off letter O, and then letter P, letter E, and letter N. And lastly, it will turn off all the letter and also all the running light. And after that, we have LBRA forever. The LBRA is just the same function as JSR, but JSR is a calling function for delay, but LBRA is a calling function for a loop. LBRA forever will loop the forever, which is at the top, as earlier. It will loop from the beginning until the LBRA, and it will repeat it forever. Next is the delay coding for the D500 millisecond, which I said earlier, which is the sun. First, it will begin with origin $1400. This is where we set the origin of the address 1400. The reason why we did not set it as the same as the mother origin, where the mother origin is $1000, but the sun origin is $1400, is because we don't want the memory to clash with each other. If we assign the origin is the same as the mother, then the memory in the mother address will be replaced by the sun, and the coding will be chaos. Next is LDX hash 250, where we assign 250 in decimal into X. This 250 is for cycle for the delay to make it until 500 millisecond. Next is load Y hash 12,000. This is where we assign 12,000 into Y, and this is to set the period in millisecond. As we can see, this is the equation to get the period in millisecond. The 12,000 we times by 4. The 4 is the cycle, which is from DEY. DEY is the function to make 1 cycle, and BNE is the function to make for 3 cycle. And we plus it, we get 4. And this cycle we times by the 12,000 that we set in Y, and we will get 48,000 cycle. And for 48,000 cycle, it will produce 2 millisecond, because the origin of the equation is that 6,000 times 4, we will get 1 millisecond. So if you want to get 2 millisecond, we just times the 6,000 by 2, and we will get 12,000 to get 2 millisecond. And after that, this 2 millisecond will multiply with 250, which is the cycle, where 1 cycle will delay for 1 millisecond, and it will repeat it until 250 times. At the BNE delay, it will repeat it for 250 times, where each repeat it will delay for 1 millisecond, and it will end at RTS. Next is the delay 300 millisecond, where it will start at the origin 1400, same as the delay 500 millisecond. The reason why we set it the same is because this is only the origin for the delay for the sun and not for the mother. And if for the sun we set the origin is the same, it doesn't affect any coding at the mother, it just only affect at the sun. And next we set LDX hash 100. We assign 100 in decimal into X. This 100 is the cycle it takes, where one cycle it has 3 millisecond, and it will repeat it at 3 millisecond until 100 times to obtain the 300 millisecond. And next is 18 hash 18,000. We set to Y. This is to obtain the 3 millisecond. The equation is fixed. It is the same as the delay 500 millisecond. And the 4 is as I have explained at the delay 500 millisecond. This is the addition of cycle at DY, where the instruction takes 1 cycle. BNE, the instruction takes 3 cycle, and it will produce 4 cycle. And when the LDY times by the 4 cycle, it will get a 3 millisecond, and it will repeat it for 100 cycle at the BNE delay, and it will end it the same as the RTS. And lastly, N is to end the coding.
So now I'm going to show you guys about the result. Alright, that's all from us. Thank you for watching.